Tonight's program is one that likely garners a lot of interest, focused around recent news reports that came out this spring of charging the Golden State Killer and using DNA databases, so GEDmatch, a DNA database that is used for genealogical purposes to identify a suspect in that particular crime. It's actually another case that just hit the news today, another case that hit the news last week. So 3 different cases of using genealogical databases to charge suspects of particular cold cases. And so that's going to be the focus of what we're going to talk about tonight. There's likely going to be a lot of interest in question and discussion, and so we would appreciate if you would hold your questions until afterwards. We will have time for Q&A and discussion after the presentation. Eric will be introducing some of the uses of DNA in forensics, the use of genealogical databases in a way that you could use to identify a particular crime suspect, and then Anya will be talking about some of the legal implications of this particular application of DNA technologies. And so Eric will start us off.
Okay, thank you for the introduction, and thank you everyone for coming tonight. We'll just dive right in. So an overview for the meeting, I'm going to be talking about the historical context of the use of DNA and associated databases for the identification of criminal suspects. Then we'll be talking about advances in DNA technology and the combined use of information from DNA and genealogy to identify criminal suspects, which was recently garnered national attention through the Golden State Killer case. I'll turn it over then to Anya, who will be discussing the privacy and legal implications of these advances in DNA technology, which of course is of considerable interest to the attendees of this meeting, many of whom have taken genetic testing kits through 23andMe, Ancestry, or Family Tree DNA, and then finally we'll have time for questions at the end. So in general, DNA testing can be used to match several elements surrounding a crime scene. So the crime scenes themselves, suspects, victims of crimes, etc. There's a variety of tissues that investigators can use, which are listed here in terms of examples that can be sources of DNA. One problem with using DNA in forensics is that most of the DNA in the human genome is identical from individual to individual. So we can't take any old sequence of DNA, get the sequence information for it, and then expect that it will be a unique identifier for an individual. We instead need to focus on those regions that are variable among humans in the population. And so the combined DNA index system, abbreviated CODIS, is a hierarchical database that stores information about these variable sites. And so shown up on this slide is basically a chromosome map of the human genome. We have 22 autosomes, and then we have the X and Y sex chromosomes. So there's this a variant called AMEL that is useful for determining the sex of the suspect. And then there's 13 sites along the autosomes that are used for identification of individuals. Now, these sites are variant among members of the population because they differ in the amount of repetitive DNA that they have at those sites. So DNA can be highly repetitive, and at these specific regions, different members of the population have different lengths of these repetitive regions. And so we can find out what each individual's repeat length is at each of these sites. So here is an example image of how one might do that. Here are 3 CODIS regions highlighted by the blue boxes on the top here, and the peaks correspond to the variable repeat lengths that are possible for each region. So this first region, D3S1358, has peaks that can vary in length from 12 copies to 17 copies. And then the repeat lengths for those other regions vary. Now we can compare this as basically a size standard for developing individual profiles. So this individual profile for this Norma, we can tell what her specific variant composition is at each of these regions. The height of the peak corresponds to the number of copies that the individual has, and the placement along the horizontal axis corresponds to again, the repeat length of those variants. So at this first region, Norma has 2 copies of a single repeat length of 15, indicated by the higher peak and this sole 15 number below that peak. Both of those copies of length 15 were inherited from her mother and father. As opposed to that, in these 2 regions, Norma inherited from her mother and father 2 distinct repeat lengths, 14 and 16 in this case, and 24 and 25 in this case. Now, the reason for showing you all of that is we can compare profiles that are established from crime scene samples and profiles developed from suspects identified through relationships to the suspect or the victim per se, or proximity to the crime scene, etc. And so you can look at, visually, you can look at where the peaks are and the numbers that they correspond to. And although the numbers are hard to see in this case, you can look at the crime scene profile here and the profiles of 4 potential suspects. And so I'll let people take a second to look at this. And if there are any kind of amateur detectives that are interested in suggesting someone we should bring in for questioning, you can let me know. 3, I'm hearing 3. Yes, that's correct. So you notice that the peak profiles for suspect 3 match the profiles developed from the crime scene. And this is also helpful because it can be used as negative evidence to rule out, say, suspects 1, 2, and 4. Okay, so some advantages and disadvantages of the CODIS system. If you have a perfect match between a crime scene sample and a suspect, there's a strong inference that that suspect is the one responsible for leaving that DNA at the scene. The exact statistics depend on things such as background demographics, but in general, it is very rare that there will be an exact match at all 13 sites. Also, it's a well-supported infrastructure. So CODIS has 13 million samples currently at the national level, and there's also state and local databases as well, and they interface in order to allow investigators from different regions to communicate with one another and talk about proceeding in the event that there is a match identified. Some disadvantages are that there are 13 regions that are sampled. So for example, if the sample is degraded or if for some reason you can't obtain the repeat information at one of the sites, there's a considerable drop-off in the statistical inference that you can make regarding the identity of that individual. Familial searching is not robust. So again, noting that the inheritance from parents to offspring can be uneven, so I don't necessarily share the same variants as my brother. So if I have my sample on CODIS and my brother has sample on CODIS, the likelihood that we have identical CODIS markers is very rare. So your ability to identify suspects through family relations is not really a tenable solution for this method. There's a demographic bias, so depending on your likely ethnicity of your suspect, you may be more or less successful in identifying a potential suspect. And DNA evidence is also not absolute proof of involvement. So there's actually a local example where a man was charged with sexual assault due to the presence of a single sperm cell on the victim of a sexual assault case. The circumstances surrounding this incident were that the victim was at the suspect's apartment. However, the suspect turned over phone records and witness testimony confirming that he was out of the city during this incident. Despite those pieces of data, the investigators pushed forward in implicating him in this crime. What later became apparent is there was an alternative explanation for the transfer of that single sperm cell to the victim. So he was cleared of this, and now he's turned over to suing Iowa City. So this is just a cautionary tale for DNA evidence of any kind and not being absolute in the implication of people in committing crimes. So we're going to transition now and talk about the advances in DNA analysis and their use of identifying people through genealogical records. This is a snapshot taken from this company called Parabon, and they're promoting the use of genetic genealogy to identify suspects in criminal cases. The Golden State Killer case has gained national attention. And one of the most prominent threads of discourse in these headlines are, what are the implications for individual privacy? Millions of people have uploaded their genetic profiles to testing companies like 23andMe, Ancestry, FamilyTreeDNA, and so are these potential resources for future criminal investigations? People are concerned about this, and this is something that we can discuss later. So the details surrounding the Golden State Killer case. The Golden State Killer committed a series of rapes in the late 70s in the Sacramento area, and then about a dozen murders suspected in the Southern California in the early and mid 80s. This man, Joseph James DeAngelo, was arrested late April, the suspected Golden State Killer. And the news reports have confirmed that genetic genealogy, and specifically the GEDmatch platform, was used in the identification of DeAngelo. We don't know the exact protocol that was used by the investigators, but that's the purpose of this session, is to provide kind of an example of workflow of how someone would go about doing that. And so again, genetic genealogy uses the combined information from DNA and genealogical records to establish links between individuals. And the way that this would be applied in forensics is analogous to what someone would do, say you're a person with an interest in recreational genealogy, looking for relatives. You would perform a similar set of steps. In this case, we would upload our crime scene DNA to a database, such as GEDmatch. And a computational algorithm would then place our sample within some degree of relatedness to other samples that are available on the database. Now, we don't know the genealogical history of our crime scene sample, but what we do know is that these blue individuals, these DNA matches, are actual people that we can look into and we can investigate. So we can find information about the ancestors of these individuals, and then we can use this combined information to kind of narrow down the identity of our suspect. And how we do that is by reconstructing an extended genealogy of these common ancestors and then using these genetic relationships to narrow our search window. And I'll talk about how we can go about doing that. Before we go any further, I just want to offer a brief disclaimer in that we're using test kits for demonstration purposes, but these test kits have no relation to the Golden State Killer case. So the first step is what we would take is we would get the DNA from the crime scene, and then we would genotype the DNA. Again, we're not sequencing the entire genome in this case. We're focusing only on sites that tend to vary among humans. And how we do that is we get sequence data specifically at sites that we know to be variable. In blue is our DNA sample that we're investigating, and in gray here is a flanking region that is complementary to that DNA sequence. When those sequences pair, what follows is a sequencing reaction that produces a single base. And that production of a base is accompanied by emission of a fluorescent tag that will be a particular color based on what nucleotide it is. In this case, the T base produces a red fluorescent tag, and the C base produces a green fluorescent tag. Now, a chip platform that is used by a lot of DNA testing companies today contains hundreds and thousands of these variable sites. And so these sites will glow one of three colors, either green, yellow, or blue, depending on the variants that you inherit from your parents. The next step after sequencing or genotyping the raw data would be uploading that file to GEDmatch. So this is just a snapshot of the home page of GEDmatch. Broadly, GEDmatch is a third-party platform that allows for the uploading of DNA data from several databases such as Ancestry, 23andMe, Family Tree DNA, and others, and allows for the comparison of those kits. Here's the link that you would click to upload your own DNA, and here's what the file looks like. And so the reason that I show this is to just demonstrate its simplicity. There's 4 columns, the unique variant ID, the chromosome on which that variant is located, the chromosomal position, and the genotype information at each variant position. And so it's perfectly reasonable to presume that investigators could send the crime scene sample to a lab, get that sample genotyped, get the raw data back, and then reformat it into this simple structure that is then interpretable by GEDmatch. After we've uploaded our sample, we then perform a one-to-many comparison. Now, this test is very much analogous to what is going on behind the scenes on platforms such as 23andMe and Ancestry when they provide you with a list of DNA matches. It's essentially matching your submitted sample to the samples that are available on that database. And so the principle of that matching is demonstrated in this cartoon example. So for simplicity's sake, we're only going to consider the passage of this blue chromosome from this father right here. Now, during the passage from one generation to the next, there is this reshuffling of genetic material so that all of the offspring of a single individual might not share exactly identical copies of chromosomes. And that's shown in this example below. So this father's son gained this entire blue chromosome where this daughter received only half. And so there was an exchange reshuffling event that happened between this region during reproduction and the generation of the new offspring. Another reshuffling event happened right here. When you match samples on these DNA databases, they take advantage of shared segments of DNA. So if we submitted our crime scene DNA sample, it would generate a match corresponding to this segment of DNA. On DNA websites such as GEDmatch, this is also referred to as a shared centimorgan. So a centimorgan is essentially a unit of shared DNA. And I'll show one additional generation here. In this example, this daughter completely lost the blue chromosome. And the reason that I show this as part of the example is to emphasize that as you increase the degrees of separation between individuals in a genealogy, the number of shared segments or shared centimorgans between those individuals becomes smaller, and it becomes harder to interpret relatedness. So really, if we're looking to hone in on a criminal suspect, we want to focus on those individuals with the highest number of identical segments or highest shared centimorgans. All right, so when we submit our DNA sample to GEDmatch, we get this unique ID number, and then the one-to-many comparison produces several rows, each corresponding to unique kits. Now, I'm not going to go through this table in too much detail, but I want to highlight these columns right here, in that the total centimorgans shared between our kit and these top two rows are in the 3,500 level and are much greater than the rest of these rows, which are dropped down to below 100. So we're going to eliminate those people from the investigation just because they're too distant from our sample to be able to investigate more closely. The largest centimorgan is the largest segment shared between the test kits. And the generation value is the number of generations separating the matches from our suspect in this case. Now, what is shown here is a graphic that shows how our submitted sample, which would be the self in this case, relates to any degree of familial relationships and the amount of shared centimorgans expected in those relationships. Now, it's probably pretty difficult to see the precise numbers, and I'm not going to go through this graphic in any comprehensive way. I just want to highlight that the greatest number of shared centimorgans in any familial relationship is a parent-to-child relationship with a value of about 3,500 shared centimorgans. And that's the value that we recover for these matches. So we can infer from that connection that our submitted sample and these matches represent a parent-child relationship. But we don't know which one of these scenarios is true. Either our submitted sample is the son of these two individuals, or is the father of these two individuals. One additional piece of evidence that might help in looking at maternal versus paternal lineage is this shared X DNA. So we know that our sample is indeed male because in male-to-male inheritance, you're going to pass along your Y chromosome, and you're expected not to share any of your X chromosome in DNA. And we see that there's 0 centimorgans shared in those two samples from this male individual and our sample. However, the passage of genetic information from fathers to daughters or mothers to sons involves the passage of an X chromosome, and therefore the shared X DNA there. However, this data doesn't help us interpret between these two scenarios. These two scenarios could still be true under those circumstances. What is helpful, though, is by analyzing the matches of the matches. And GEDmatch actually enables us to do this. We can click this link to basically show what kits match to this individual. The reason that that is helpful is that under this scenario, not only are these two individuals related to this person through their common paternal link, but they're also related to each other, they should be expected to share some segments of DNA, being both offspring of that common father. However, if this scenario is correct, unless there is some heavy inbreeding occurring, we would expect that the amount of shared DNA in those two kits or individuals would be low. So when we click on that link and we look at the matches for this individual in this graphic here, we see the first match is to our original sample, M35-1300, but our second match is a test that we don't recognize. So from those results, we can make the inference that this scenario is correct, that the criminal is the son of these two individuals. So once we've identified people that we want to kind of investigate for the identity of the suspect, we use this workflow of combining the DNA information and the genealogical records. So just kind of to reiterate the point, we use shared centimorgans to assign a general window of relatedness with higher shared centimorgans reflecting a closer genealogical relationship. We use the historical records of ancestors as a piece of information. In this cartoon example, we identify that the grandparents of this individual are the same exact people as the great-grandparents of this individual. What we can then do is we can identify who all the descendants of these two people are, and then use the relationships between these test kits to make an inference on who our suspect might be. Spoiler alert, this shared centimorgan value is reflective of an aunt-uncle, niece-nephew relationship. This shared centimorgan value is reflective of a second cousin relationship. And so after mapping out all the genealogical information, this is the only individual that fits both of those in terms of the genealogical record and the DNA matches. If there were more sons here, if there were more males here, those would be additional suspects that we would want to investigate. Now, doing genealogical descendants research on GEDmatch is perhaps even easier than it is on a site like Ancestry or 23andMe. And that is because all the kits are associated with the names of the people who submitted that data and the emails. So you can directly contact those individuals. The investigative tech team may have contacted the match of the Golden State Killer and said, hey, we're the police, you better cooperate, we need information about your family. Or since a lot of people on these databases are enthusiastic in genealogy, they might have come under the presumption that they were looking for long-lost relatives, and they may have just cooperated based on that shared presumed interest. We don't know. But additionally, in some cases, we can get the genealogical information straight from GEDmatch. On clicking on this wiki link, we have access, in this example, to 254 relatives of this Judy Lane. Now, this has to be uploaded by the individual themselves. So this isn't going to be available for every match that's on GEDmatch. But in particular instances, this might be accessible. If we click on this individual, Judy Lane specifically, we see more information about her specifically. And to the interest of our investigation, we have identified 3 sons that she has that might be suspects for our mock criminal investigation. I'll leave it up to you as to who the identity of our unknown kit is, but in general, you could use information such as the age of the individuals, where they live, whether they're alive or deceased, and you can use that information to maybe narrow your window of who to investigate. But in the Golden State Killer case, the investigators very much likely had direct access to genealogical information or compliance from a family member. After you've identified a putative suspect, you can then get their DNA. And in this case, they retrieved a publicly discarded sample from DeAngelo, matched it, got the genotype information from it, and found that it was a match to the DNA from the crime scenes. Okay, I'm going to just skip over this in interest of mentioning a couple final points here. As Bryant mentioned at the beginning of the program, the question then becomes, is this going to become more widely practiced in terms of a criminal investigative technique? There are a couple sample examples of cases that have come out very recently using similar techniques to identify likely culprits of crimes. And then for the purely romantic, we can look at other notable criminal cases and just ponder whether it might be possible to identify these people. What probably isn't as intuitive just reading from the headlines is there are probably lots of cases that have not been documented in the news where investigators have tried to submit samples to these sites and either not retrieved matches or the matches were so distant that it really did not enable further investigation of this. And so again, this data set really enables familial searching, but it does have its limitations. And the final point that I wanted to make is just regarding a technical limitation in terms of uploading your data to a platform like Ancestry or 23andMe. And so basically all that you would have to do to get your crime scene sample uploaded onto those databases would be to falsify the sample and make it appear as though it were a saliva sample, put it in their sample tube that they give you in the kit, and then send it off to the company and they'll create the genotype data for you and show you the matches. And so I reached out to Ancestry and 23andMe with this specific question on whether or not they do quality control measures to detect, say, a falsified sample. And Ancestry never got back to me, but 23andMe replied with this statement that we appreciate your interest but cannot speculate on unrealized hypothetical scenarios. And so they really didn't address whether or not they actually employ any techniques to detect this. They have made statements in the news that they were not contacted by law enforcement agencies in the identification of the Golden State Killer, but there isn't any reason to believe at this point that there may be some samples from suspected criminals on these databases. So that's all I have for my portion. And so I'm going to turn it over to Anya.
All right. Thank you very much. So I will talk about some of the privacy and legal considerations, of which there are many that you, I'm sure, are already thinking of. But I'll give a little background as soon as I can clip this in. Okay. So what are some of the privacy and legal considerations of this? So I want to go back to Fourth Amendment, right? We have constitutional protections against what the police can do, right? And so Fourth Amendment protects against warrantless searches, right? The police need individualized suspicion and reasonableness to get a warrant to search somebody's house, right? And so the point of the Fourth Amendment is to limit government surveillance without individualized suspicion, right? We don't necessarily want a situation where we say, you know what, there was a crime that happened on the north side, so what we're going to do is get everybody's DNA who lives in the north side, problem solved, right? We don't want that sort of situation because there's not individualized suspicion. It's supposed to narrow it down a little bit and say, well, we think it's one of these 5 people who might have been in the area based on other information, right? However, data from a third party that's given voluntarily doesn't need a warrant, right? So if you go to somebody else and say, where was this person, or can I have this document? It's part of the third party doctrine of the Fourth Amendment that says you don't need a warrant if somebody says, here's my information. So if you go to GEDmatch and the person has voluntarily shared their information, or investigators knock on Ancestry.com's door, I don't even know if they have a door, they email them and say, would you be willing to give us this information? And if Ancestry or any of these companies said, sure, here you go, then that's the third-party doctrine, right? It was given voluntarily, and so the person doesn't have an expectation of privacy once they've given that information out into that world, and that third party can give it elsewhere, right? But a week ago, the Supreme Court ruled on a case called Carpenter v. the U.S. Now, this was a cell phone data case, and the question was whether the police need a warrant to get location information from cell phone towers. So under the third-party doctrine, the police go to the cell phone companies and say, hey, can you get the location information of this? And they say, sure, here it is. It didn't need a warrant. In Carpenter v. U.S., they said, yes, the police do need a warrant, right? It's a big, long opinion. There's lots of nuance to it. But it essentially is changing the third-party doctrine as of a week ago, and so it's a little unclear what that is going to mean for other things like genetic services, right? Now, does that change the requirements of what the police need to access a genetic database or something like that? If we think about DNA testing in criminal law, it's not new, right? This is not a new thing. We have had constitutional cases about whether or not we can collect DNA from suspects. And states across the country get DNA anytime somebody is convicted of a crime, right? And this includes felony convictions, but often it includes some misdemeanor convictions or just all convictions in general, right? So if you think about shoplifting or something that's not some violent crime, and that person has been convicted of that, their DNA is going to be in that CODIS system that Eric was talking about. And then, so that was the first part of it. They said, okay, we're going to collect DNA from criminals, right? Convicted criminals, they're dangerous. We want to make sure that there's not recidivism. We want to be able to solve crimes. And then we moved a little bit further where we said, well, let's also collect this for arrests, right? So now, in many states, if you're arrested, right, you're not convicted, innocent until proven guilty, but if you're arrested upon booking, they take your DNA. And for some, it's misdemeanors as well as felony arrests. Some narrow it to violent crimes, and some apply to juveniles, right? So you could be 16, arrested for a misdemeanor, and your DNA is now in the system, right? And there was a Supreme Court case and some case law about that of, well, is it constitutional then to take somebody's DNA upon arrest? And they said, well, yes. It's reasonable because we need it for identification. It's like a fingerprint. We want to make sure that we have the right person there, right? The dissent said, that's ridiculous. We can use fingerprints. Also, it takes so long to do these matches. It's not about this. It's really about collecting and amassing these DNA biobanks. So there's some discussion about this from just the criminal side, right? So we're sort of, the slippery slope is the term in law that we use, and we're sort of going down it, right? First we collect DNA from convicted criminals, then we collect it from people who are arrested, and then we say, what about familial searches and criminal biobanks? So California was the very first state to approve the use of familial searches in criminal biobanks. Again, this is the first part that Eric was talking about using CODIS to match this, right? And I grew up in California. Apparently, we have a ton of serial killers that need to be caught because the first publicized case of familial searches being used was somebody called the Grim Sleeper, who was suspected in a horrible number of murders. There was DNA evidence collected, but never a match. Well, they said, well, why don't we look for partial matches in this search? And they found a match for a man in prison for felony weapons crimes. He was too young, right? He couldn't have committed the crimes. First off, it's a partial match. Second off, he wasn't old enough to match the profile. So they said, well, let's look one generation up. And they suspected his father. In that, they went to Chuck E. Cheese. He was at a birthday party. And they took a cup from him. Maybe somebody acted like the waiter, or they took it out of the trash. Now, legally, right, that's abandoned property. You don't have that expectation of privacy in your abandoned property, so there's no need for a warrant for that abandoned property. But if you think of how much DNA every single one of us is abandoning at this very moment, right, we can't really control that. I'm shedding hair and skin, and so we're abandoning DNA all the time, right? So it gets this where you can have this suspicion that it's this person. You can then go and get their abandoned property, right? If I leave a couch on the street, somebody can take it, and I don't have interest. I don't have a property interest in that anymore. If I leave a cup on the table and walk away and throw it in the trash can, I've abandoned it, right? So then they can match it up, and then they can say, look, now we have our person, now we have this individualized suspicion. Maybe then you go and get a warrant for looking into for a murder weapon or for more information about their whereabouts or whatever the case is, or just arrest them, right? So this Grim Sleeper was arrested in 2010, and he was actually sentenced to death in 2016 for the murder of 10 women. So there's still some unsolved crimes. He might have done that, and they just couldn't find enough evidence, or we don't really know, right? One thing I will say, when California set this up and said, yes, it is okay to use CODIS or the state version of CODIS for familial searches, they set some parameters around it. And they said it needs to be an unsolved case that's really serious, and you've exhausted all sorts of other possible paths. Right? So they set some parameters around how often we want to look at family to implicate other people. And there's a lot of reasons why we might want to do that, but one that Eric hinted at is because of injustices in our criminal justice system, the majority, or maybe not the majority, but African Americans are disproportionately represented in these biobanks because they're disproportionately arrested, they're disproportionately convicted, and so we have a situation where more and more people of minority populations could be arrested under this, not because they commit crime any more often, but just because we're perpetuating these social stereotypes and these injustices over and over and over again. While I'm on that topic, the interesting thing about the public databases is who makes up the majority of Ancestry. Europeans, right? So maybe we're evening out the playing field by now the police having access to this, right? So it's different privacy considerations and different implications for different communities between these. Not to say that there's not Caucasians in CODIS, and not to say there's not African Americans in these databases, but just in terms of who it's affecting most. I heard that, you guys might know numbers better, but if GED gets something like a couple million more people, and that's not that many, they'll be able to link every single Caucasian or European American just because of how many people they can triangulate, right? So we're all going to be identifiable in this, whether or not we've put our information on pretty soon. Okay, so the question from the legal perspective is, does the familial search of the public database amount to an illegal search and seizure, or should it, right? If we think back to Fourth Amendment, should it stop this from happening? And if we think about how California said, no, we're only going to allow familial searches in this specific context, are the police just skirting that law to then be able to use this? Granted, the Golden State Killer was very similar, unsolved crime, serious crime, seems like they had exhausted things, but what's to stop them then from just using this for any old crime, right? I'm just gonna flag, it's terribly important to solve these crimes, right? It's terribly, like, I'm always wearing the privacy hat and a little bit, you know, don't want this information used in the same way. That's not to say I'm against catching serious criminals, but just there's other concerns, right? Okay, so what are some of the legal questions that come up? One is, what are the user agreements of these websites? So when you read through the entire thing before clicking, yes, I agree, and lawyers don't do that either, it's fine. What does it say, right? Does it say you can only use this information? In a second, I'll talk about an Ancestry.com case, but Ancestry and 23andMe have gone away from use in criminal by law enforcement, right? So they say, you know, we want this to not be for that. GEDmatch, after this occurrence, said, yes, absolutely, your information, if you upload this, could be used to solve crimes, and it's well known, right? So there's differences in how these companies have addressed this, but GED has very much been, yeah, come on, use this to solve crimes, feel free to upload these profiles, right? There's a question about whether if the police uploaded something that was the user agreement, what the actual implications would be, like who would be able to stand up, right? We're not sure that like 23andMe would go against that. So it's a little complicated even if there is a user agreement, but it's just interesting in how these companies are portraying themselves. This is also not perfect, right? For every match that you get, the police probably went through lots of people that were partial matches that they thought it could be. Eric mentioned, you know, there's a lot of stories we don't hear about, right? And one, I think, are false positives. And one story that we did hear about is Ursi. This was a few years back, maybe early 2010s. There was a murder, maybe in South Dakota, I'm forgetting the state right now. Idaho, thank you, one of those Western states. So, and big, you know, okay. So there was a murder in Idaho, and they were looking for the crime. And so they went to Ancestry, and Ancestry had a public database, and so they found information on that public database, they found a partial match, and they started looking at the partial matches. And they found this man in Florida who spent some time in Idaho, and it was a murder case, I don't know if I mentioned that, but lo and behold, he was a horror film director. So he had to have committed it, right? Here's this person who likes horror films and is awful. So they go, they knock on his door one morning, and then they say, hey, come with us to the police station. And it turns out he wasn't a match, right? Well, that's fine, right? What's the harm? But if they had showed up to his work, if he couldn't have gone to work that day because he was working with the police, if they had actually arrested him, if they hadn't have figured that out soon enough, right? There's all sorts of implications that could come from these false information. So Ancestry, after this happened, actually shut down its public-facing website. And they said, we now see some of the problems that could happen by having this public database, so they changed it so that it couldn't be used for these purposes. So we see a very different reaction from Ancestry than we do from GEDmatch, where after this happened on GEDmatch, they said, yes, use this for criminal investigations. Ancestry said, whoa, no, we don't want that to happen to our people. Now, that doesn't mean that the police don't still ask for information in 23andMe and Ancestry. Those companies have said that they will need a warrant, right? It doesn't mean that the police can't get a warrant to ask for that information, right? But in terms of just asking under the third-party doctrine, those companies have publicly said, well, we're not going to cooperate as much, and we're going to try to narrow the public facing, as opposed to GED, who says, yes, absolutely, we'll still have this be open. I talked about that. Okay, so I'll just throw out a couple of the policy impacts and questions, and we can, I'm sure, have a lively discussion of all of these implications. One question that's really just a question about Fourth Amendment is this, well, what do I have to lose? Do I really care that if I put information on GEDmatch, that the police could use it, right? I don't have anything to hide. I haven't committed a crime. If they want to look into me, okay, what's the harm, right? And I think that could be a legitimate thing, right? We can say, well, this helps us to solve crimes, and it doesn't necessarily hurt that. But if you think about the Fourth Amendment, it's against that tension, right? We might not have anything to hide in our house, but we still don't necessarily want the police to be able to come and walk in any day, right? So it's just a question of where we want that principle of government surveillance versus ability to investigate crimes, and where we want to set those bounds, right? But it's really a question of sort of Fourth Amendment, and is the problem search in general, or is the problem search that leads to some evidence, right? And so just a thought to throw out to the group, right? There's also questions about what this is going to do, what impact this will have on research or DTC testing, right? How many people may have not done ancestry testing in the last month and a half, or not participated in research because they're now worried about some of these law enforcement implications? And is that a balance we want to make in society, right? Is it better to solve some of these crimes, or is it better to protect the confidentiality more? Interestingly, the 21st Century Cures Act, which passed Congress last year or two, certificates of confidentiality existed, and what they are is they're in a research project. They will have a certificate of confidentiality that says, we will not disclose research data to law enforcement, right? And this now in 21st Century Cures means that any research project that is using genetic information will have these certificates of confidentiality. The question is whether that will stand up in court, right? If you're subpoenaed or you have a warrant and it says we need that data, is that really going to hold up? Where you say, no, I have this certificate of confidentiality. There's been court cases that have gone both ways on that, although not since 21st Century Cures, so we're not quite sure how that's going to play out in the courts. But there is some movement on the congressional side to say, no, we really want this to be protected, even in the law enforcement realm, because we want to encourage participation in genomics research. I talked a bit about the racial disparities, but I think it's important to just think through what implications both the familial searches in CODIS and in criminal biobanks, and also familial searches in public databases, and what sort of impacts that has. And then there's, of course, the question and problem of, I can't control what my second cousin does, right? It is the family member's choice to put their information on these databases. You could argue that I could control what crimes I commit, and so, you know, it's my problem that I didn't commit a crime, just. So how do we balance that, right? We could have all the user agreements you want, we could have all the privacy you want, but if these are your distant family members putting this information on public databases, that's their right to do, right? And do we really want to create some sort of system where they don't have that right to do that just because it has these implications across? So that's all I have, and I'm sure there's lots of questions for both Eric, and I'd love to hear your thoughts and discuss more as a group. Thanks.
So thank you very much for the presentation. You guys can take a seat up front, and we'll have an opportunity for folks to ask questions and have discussion of those answers.
And I have the microphone because we are recording this for the library channel. So if you have a question, and I know there must be questions, let me get the microphone to you. Questions? You guys always have questions. Oh, thank you.
Must have been crystal clear.
So if there's going to be some challenges to police departments using this sort of data, where are they likely to come from? Are we going to see a few big cases that come up just to, try to get some resolution here? Where does ACLU fall on this?
Yeah, I don't, is this one? Yeah. I don't know where ACLU falls on it. They come up in criminal cases often, right? So Carpenter v. U.S., one way you can tell if it's a criminal case is often one of the parties is U.S. or the state, right? So-and-so v. California or so-and-so v. U.S. So that's a criminal case where he was convicted using cell phone data, and it went all the way up to the Supreme Court to say, no, you can't use that as evidence, right? So we could see this case coming up like that, where somebody, I don't know if there's any plans of D'Angelo, if that's brought in to be raised, but where somebody who's convicted through this kind of evidence would argue no. Before Carpenter, the third-party doctrine, I mean, you don't need a warrant for voluntary information, right? So people might not necessarily bring those cases if they think that it wouldn't go anywhere. I don't know too much about sort of the murmurings amongst the criminal law community about that. But that's where I would envision it coming up through the courts.
So I have a question. So is this such a unique approach that it's going to almost be inevitable that it's appealed? So let's assume that it does go to a conviction, that it's going to be appealed and ultimately appealed to set new legal precedents on the use of DNA data.
Yeah, I mean, I would imagine at some point one of these cases will, right? We had Maryland v. King, that was one of the arrested DNA, right? All of those, each time DNA has been taken, right, at conviction, at arrest, it's been challenged for various reasons and in different ways. One, it was a case of that collection of DNA in the criminal system was against somebody's religious beliefs. And so there's challenges all the time. And so I would imagine that it will be challenged. It's just unclear how Carpenter whether that sort of principle will apply and how much the courts take into account how pervasive this information is. So one thing in Carpenter was how pervasive cell phone data is and how much it actually shows about ourselves, right? It's very different than years ago where maybe every time you made a call, it listed which cell phone tower and what location you were at. But now with GPS and with everything, we're tracked every second, right? So that can affect it in the sense that there's just genetic information is so much more pervasive, so many more people have it online, then that could change how courts think about it. But yeah, I would imagine there will be something. It's just a question of how far it goes.
So what's the right of a relative of somebody who has shared their information? If mean, does that, the person who is also that, you know, like a sister or a brother or child, doesn't want that information there, do they have any rights in this?
Not in terms of people sharing it, right? Because it's their personal genetic information. And even in criminal cases, right, if we think in that context, nothing stops my parents, you know, if the police come knocking on the door and say, would you be willing to share your genetic information to help us out? They could say yes without a warrant, just completely voluntary. And in terms of sharing that information, that's their personal information to share, right? And so it's a challenging area in terms of privacy because it's your own. You want to be able to control it. You can do really cool things like find family members, but
You
how
can
do you-
inadvertently send somebody who's related to you to prison. I mean, not that they're not guilty, but
Yeah, and this comes up in context outside of criminal law as well. For example, in families with Huntington's disease where it's autosomal dominant. So if you have a condition, you know that it's passed down from father to son or mother to child. And so there's cases where grandparent knows that they have it and the grandchild wants to get tested and the parent doesn't. Right? And the child will find, if they find a positive test result, it implicates, right, in terms of the medical implication, the parent. So we have these situations in medicine, in criminal law, all the time where somebody might want information about themselves, whether it's for ancestry, for medical care, whatever it is, that impacts family members, and we don't have a good privacy solution for that. No, yeah.
To follow up on that, can an insurance company try and force information to, if you apply for insurance, and can they then say, all right, but you need to do a genetic test?
That's a great question. So that's actually my primary area of research, is how insurance companies use genetic information. So it depends on the state. Some states say that insurance companies can't require genetic test results. I should say health insurers cannot take into consideration genetic test results or any medical information under both the Genetic Information Non-Discrimination Act and the Affordable Care Act. But other types of insurances, life insurance, disability insurance, they could, and so in some states they could ask for that. I don't know of any companies that are actively asking for that because they just get so much data that isn't necessarily that much more helpful than just asking about family history. But it's another area of privacy concerns as well.
Yeah, I would think in the case we talked about, they would use CODIS in the end, because that's where all the precedent is. You wouldn't use any of this other stuff. You would just use this stuff to perhaps go to a judge and get a warrant to get a DNA sample. That's all you need to do.
So I know that they tried to find a CODIS match for the Golden State Killer, and there was
No, you go to you go to the judge and say, I found someone I think who has the thing. Then you get the match directly from the person.
Right.
And
Yeah.
then you use CODIS because that's easy to put through the legal system. This
Sure.
other stuff is impossible to get through the legal system, and would be very, very difficult.
So that raises a question I sort of have, is that what you're saying is that investigation doesn't become part of the trial, but it is part of the trial.
For the
correct?
judge, for the judge, they convince the judge probably, or they just use the discarded DNA sample.
The person did not become a suspect until they did the work on GEDmatch.
Yeah, if you want to follow, the chain of evidence, you have to show that the DNA sample that was discarded did belong to that person. So you have to have a chain of evidence there that's very good. Otherwise, no one would be able to convince anyone that it was you.
Yeah, so for my understanding is for the Golden State Killer, they did 2 DNA matches. So they got 2 discarded samples and double checked both of them. In terms of whether then they could just arrest and use CODIS, so I'm not a criminal lawyer, so I'm more vague on this area, but there is doctrine of fruit from the poisonous tree, right? So if you have evidence that was collected unconstitutionally, and then you get evidence, even if that's done correctly or legally, that subsequent evidence can be thrown out if the original reason was a violation. And so that happens in various criminal law cases where, you know, the police entered the house illegally and then they found drugs or something, right? So there's lots of case law on that, and so that could come into play if they tried to go that way, where somebody could argue, well, yes, you have this legitimate evidence, but the reason you got it was from this poisonous tree, right? If even that third party is a poisonous tree, right? It's that is arguably perfectly legal what they did, right?
But I don't think you have to worry about them using this in court in any way, except to go to the judge and say, look, I need a sample and this is what I got.
Yeah,
Because it's not, the samples are not in any way, they're not validated in any way. They don't even know they're from any of the samples on the website or from any of the people they say they are.
right. So they definitely validated, right? They definitely got samples directly from him and had the chain of evidence.
No, you have to get it from the people as well that supposedly were related to him, because those samples were not validated either.
Right, but they, so once they have him.
They
and
get a lot of samples from people that say they're such and such, but they're not. And they use someone else's sample that they send to 23andMe or Ancestry.
Right. I guess I'm saying even if the people in the middle weren't the right people, right? If they have him, they've gotten a discarded sample from him, and it matches via the original DNA markers.
Yeah, what I'm saying, though, is the amount of case law you have to put together to use any of this stuff would just be fantastic. And they didn't do that. They went direct, they used CODIS, I can guarantee it.
Yeah, I mean, we'll have to wait and see what the court arguments and evidence is. It's my understanding that they're, you know, following this chain, so.
What are the implications of putting a certain large group of a population into one of your databases, such as was suggested in the last week that families, children and separated adults could be tested on 23andMe and
So I'm just going to repeat the question. Is what are the implications of having multiple people in databases such as 23andMe and Ancestry, and you're referring to the publication, the news stories that 23andMe and also MyHeritage have offered to do matching to identify relationships between the immigrants that have been separated as they've crossed the border. So.
Yeah, I mean, I think there's a lot of implications. So one interesting thing is Lauresis, the organization that's one of the primary nonprofits working in this area, has actually said no thank you to 23andMe. And the quote was something like, we would be trading one human rights violation for another. And their argument was it's a privacy violation and that's not the best way to solve it. Another one of their arguments was this is a systemic problem with how we track people within the immigration system, and so that would be a Band-Aid, and they would rather go in with cases to try to fix the system at large. And so there's definitely people concerned about having population in the data bank. I think the question specific to that situation as well is who controls that, right? Is it 23andMe helping the organizations, and then what do they do with that data? Does it go in a biobank? There's also questions of how helpful it would be, and maybe you can speak to this more, but like 23andMe has predominantly European American information, and so some of their matching for Latina and Latino populations might be not as strong. So there's lots of implications for that, whether it's government controlled or private controlled. Yeah.
I want to go back to the case we were discussing. I can't remember the source. I think it was probably an article I read where someone was interviewed who'd been involved in the collection of the information to determine what happened. And they had gotten the initial information or matches on GEDmatch. Then what they did is actually several people were hired, and it took them something like 4 to 5 months to compile family histories and whatever on all of those matches. And after doing that, I mean, the person was saying this is a terribly tedious task, but when you look at what's generally available with all the people with public trees on Ancestry.com, the amount of information available on various state databases that is about, there are very few secrets about people's lives in some states' databases. And they took the months to put those together, and at the end of it, they came down to 2 individuals in tracking down the family trees that could be possible in terms of where they were, where they lived, and that sort of thing. And I think they trailed this guy for several days, and he went into some store and they got his DNA off the handle on the car. Yeah. I think you heard that part, but I think the part about anybody could, I should say Ancestry probably has no idea how many people may really use their information because of how many people have public trees.
Mm-hmm. Mm-hmm. Yeah, I think there was something like a great-grandparent or great-great-grandparent match in this, and so it was, quite broad in terms of what Eric was showing in family trees. There's also surnames you can track, right? And one of the ways they narrowed this was that a lot of that family, a lot of the branches of that family lived on the East Coast, and there was, I think, only 1 or 2 branches that had moved to the West Coast. They also profiled people with a lot of other information. They had suspected that it was somebody who'd been in law enforcement. It was, as it showed the map of California, the person moved, and so they could look at history of where he lived. So they didn't just look at the DNA evidence, right, in the family tree relations. They also looked at the person and the profile and how that person matched the profile that they had made. So yeah, there's a lot that goes into it, but privacy at large is right. You also think about just going on family members' Facebook pages and what they keep private and public. So
I would just add to that. But the DNA sample and the DNA matches is what made that person a suspect.
Absolutely, yes.
That person would have never been a suspect otherwise. And this is something I've been concerned about for several years since I enable students to take these tests for free as part of a class that I've been concerned about. And something I have told my students since I began is your participation, you better be comfortable with making one of your relatives a suspect if they happen to commit a crime. And so your participation could lead to you identifying a relative as a suspect. That's part of your participation.
Watch where you discard your DNA.
But that's the first step, is that this person or this spectrum of folks are the suspect. We're going to get additional evidence to then try to narrow down who the actual match is. And then you go in to get the verified sample to actually make the match. Yeah. But you have to use the DNA sample as an entryway into this person that would have never been a suspect beforehand, that person has become a suspect.
And just one point following up on that in terms of the sort of, well, what do I have to hide thing? If they're tracking a suspect for months or weeks, right? All of us do something wrong at some point, right? We speed, or it might not be serial killer level, but one of the reasons, there's a lot of evidence that the more that police are involved in communities, this isn't always the case, right? There's good community policing, but there's also evidence that the more police are involved, the more just arrests are made in that community, right? And so it's not, some of the concern about this isn't only the person being convicted of that crime, but you could have family members who are suspects of the crime, didn't actually do it, oh, but they actually bought some marijuana while the police were monitoring them, right? It's not outside of the realm of possibilities that they are then in the police eyesight for something completely different. And is that okay? Is that bad? They still did something wrong, right? So there's a lot of questions about that, but that's one of the reasons the sort of racial components is a thing. It's if there's just more police looking at certain areas, right, then more crime is found, not because there's more crime in those communities, but because there's just more notice.
That's one of my questions too. The police commit a lot of crimes. Does California take their DNA immediately when they join the force?
I don't know that. They may for identification purposes, I don't know. And a lot of times in terms of chain of custody, they do, right? Because if you have any contamination of samples, and so there was a suspected serial killer a while back, and it turns out it was the lab technician because her DNA kept on getting in the samples. It wasn't actually her committing the crime, she was just in. So DNA evidence does not mean that you committed the crime by any means.
What other entities besides the police can you kind of foresee making a case for wanting access to these public databases? I guess I'm thinking like maybe insurance companies or something along those lines. What other cases can you think of?
Yeah, I mean, I think there's a lot of different ones that could. I don't think we're there yet in it being cheap enough and worth their time to do, but maybe at some point we would for, insurance, employers, right? Employers are also covered under the Genetic Information Non-Discrimination Act, most employers, so they're not supposed to use that.
It just seems like when you start getting millions of samples that insurance companies have to be salivating at getting after it somehow to figure out how they can use it somehow.
The question is how much, so insurance companies make the decision of cost benefit, right? So how costly is it for them to do this analysis at this point versus the benefit they get from it? And I think at this point, it's not worth them to go fishing around so much, right? But things are getting cheaper. The more people that have information online, that makes it cheaper. So you could see this in the future.
So is there the type of information that are already in these databases is not really something that they could use?
Yeah, well, so for the ancestry side, the markers don't link to health information, is my understanding, right? So insurance companies wouldn't care about that. If they match family members to medical records or something like that, right? They would have to take one extra step of what's the family relationship and then what medical information do we have about that person. But just the sort of identification, the repeats don't say anything about health status.
So I'll just add a little bit to that. As I gave a talk to the Bettendorf Rotary Club on DNA testing and the different platforms. And a member of the audience came up to me afterwards, and his profession was a computer forensics expert. And he said, well, you really should warn people that if their data hasn't been stolen already, it will be. And he sort of laid out the scenario of some foreign agent breaking into the Ancestry or 23andMe database, collecting that data, sort of coming up with essentially a scoring value for each profile on their health risk, and then selling that to the insurance company as a score, negative or positive score on you. And so he said that's inevitable. I don't know if I believe him, but that was his assertion anyway.
Yeah, it's like a credit score.
Right.
You also have your health.
There's one question in back.
Hang on just a
We'll
sec.
finish on this one, and then we'll call it an evening.
So I'm back on Eric's side for a minute, where you were talking about the process of doing the research when someone's trying to sort out what's going on. Was it the GEDmatch people that did that, or did I hear you say that the police hired someone? In other words, who was it that would go in and do the research that you were doing, or that you were showing an example of, to try to sort out, is this guy a crook, or can we figure out from a DNA sample how to get from, you know, this coffee cup to a person? Who would actually do that? Is that a new branch of forensics, or?
So we don't know the exact individuals that were responsible for that. It would likely be someone in the investigative team itself, or someone hired by the investigative team with expertise in genealogy to be able to, as was mentioned, reconstruct a detailed, going back, you know, at least a couple generations, to ascertain what all the relationships were and come up with a list of potential suspects. So the people at GEDmatch, I don't exactly know how many people are a part of that organization, but basically they just provide a platform for just research and maintenance purposes. I don't know if they have a team that's involved in any specific research with their data set. They're just trying to provide an open platform for people to conduct their own personal research.
I'll just add that Parabon company that Eric showed that offers the service, they have advertised as part of their service to law enforcement agencies that they were involved. And so presumably at some level they were involved. It was also recently announced that they essentially hired C.C. Moore, who's a very well-known genetic genealogist and has been part of the genetic genealogy community for a long time. She's part of what runs Finding Your Roots on PBS. And so she has basically been contracted out by Parabon to do some of their genetic genealogy research.
That company also does sketches, facial sketches from DNA to say, here's what the suspect may look like.
And that would be the same data that they would upload to GEDmatch as well. And so that same DNA data they use to infer the way someone looks is also the same data they would upload. And just to sort of point out that Cedar Rapids, there was a case there in the news about 1.5 years ago where they did use that facial profiling service of this company to come out with a facial profile. So presumably that person's DNA would also have been put on one of these websites. And I'll just leave you with this last point. The fact that there are now 3 reported successes means that there's many, many samples out there, because each of you that does genealogical research knows how difficult it can be to make sense of your matches. And the reality that they had 3 successes means that they have a lot of samples waiting to be successes until they get a close enough match to come into the database. And so the reality is that there's many, many more samples out there in order to get these 3 successes. So I'll leave you with that.
Thank you.